This is question 17 from the second CSAT sample paper. We've asked the question in two parts. The first part is, how many ways are there to place the numbers 1 to n in n buckets without leaving any buckets empty? And the second part is, how many ways are there to place the numbers 1 to n in n buckets, leaving exactly one bucket empty? So if you want to have a go at this question yourself, pause the video now. Okay, so the first part should be easy. I think it's mostly to give you a hint for the second part. We've got n things in n buckets, there's got to be one in each bucket. Unless you try to do something clever like putting one bucket in another bucket, but I think that's meant to be ruled out by the question. So we've got n things in n buckets, so the only thing that affects the number of ways of doing it is the number of orders we can put them in, because we could put different numbers in different buckets. So basically look at the number of orders of n things, which is just n factorial. So our answer to the first part is just n factorial. How about the second part, where we want one bucket to be empty? What does that mean is going to happen? Well, we can imagine taking one thing out of one bucket and putting it in another. So we put two buckets together. So we put two numbers together. So one of the things that affects the number of ways we can do this is how many ways of pairing up the numbers are there. Like, we could take the 20 out of, if n is bigger than 20, we could take 20 out of its bucket and put it in the same bucket as 19. But we could have put it in the same bucket as 18 or 7 or 6 or whatever. So how many ways are there to pair up two of the numbers? Well, we're definitely just taking two. If we put 3 together, then there'd be 2 empty buckets. So there's only one pair of two things, and the number of ways of doing that is just n choose 2, or n times n minus 1 over 2. That's because there's n ways of choosing the thing we take out of its bucket, and n minus 1 ways of choosing the thing we put it in with, but we have to divide by 2 because we could swap the first and the second, it would be the same pair. So there's n times n minus 1 over 2 choices of pair. And now, how many ways can we order those things? There's two ways of thinking about this. I think the one that's slightly easier to think through, although it's a little bit longer to work out, is, first of all, there's one empty bucket and a bunch of full buckets. So we have to think about how many ways there are of choosing which one is empty. But that's easy, there's n choices of the empty bucket. And then, how many ways are there of ordering the things? There's now n plus 1 things. There's one pair, and then there's n minus 2 single numbers, which get ordered in the remaining n minus 1 buckets. So we don't care about the identity of any of those things, we just care about the number of orders. So the number of orders is going to be n minus 1 factorial. Just going back a step, what was the other way of doing this? The other way is to think of there as being n things we can put into buckets. We can put in n minus 2 ordinary numbers, we can put in one pair of numbers, or we could put in an empty space. So we could treat the empty space as like the nth thing, and then we'd have n factorial things instead. Bear in mind here we've got n choices times n minus 1 factorial, that gives us n factorial anyway, so we get the same answer. So our answer is just going to be the product of all these choices we can make. So we've got n times n minus 1 over 2, choices of the pair of numbers, times n choices of the empty bucket, times n minus 1 orders of the remaining entries in the non-empty buckets. And therefore, if we just simplify this, n minus 1 factorial is n factorial, and then if we put that on top, we can't really simplify anymore. So the answer is n times n minus 1 times n factorial all over 2.